Welcome to this edition of the Power Platform Well-Architected Framework. Today we're going to discuss how to define a resiliency strategy. My name is Ali Yousefi. I'm a Principal Cloud Solution Architect with Microsoft. You'll find my email and LinkedIn information on this slide. Some of my certifications include Azure DevOps, Azure Solutions, Dynamics and Power Platform Architects, as well as MCT, and then some MCSE Cloud Platform Infrastructure Business Applications. So in this session, we're going to start with, resiliency, why is it needed? We'll start going into, how to get started with it, just covering some terminology, how to assess your current state, where you're at in the application lifecycle, and then how to plan to add resiliency or strengthen your resiliency posture. From there, we'll go into resiliency strategies and tools, specifically focusing on code refactoring and quality, error handling, testing, monitoring, BCDR. And we'll go into considerations and next steps. So why is this needed for a SaaS workload? So why exactly is resiliency a big deal for SaaS workloads? Well, with IaaS workloads, the infrastructure, the resiliency responsibility shifts primarily to the customer. There can be outages, obviously, by the provider who provides the services you're using, but to keep things resilient, a lot of that is onto the customer. But SaaS is quite different, right? With the licensing, with the sort of the agreements that you have, you come with an SLA and so on. So why is this really important for SaaS workloads? Well, if you think about resiliency, it's not just the infrastructure having replicated machines or databases or anything like that. What it would be, though, is how do we design our solution? Do we have that proper sort of architecture? Has our code been reviewed for deployments? Do we have quality gates, et cetera? So how is the design of this? Do we have proper monitoring in place to ensure that we can get within that black box at times that would be considered a SaaS application, setting up alerting and so on, as well as testing from both shift left to unit testing to shift right, where we have our sort of non-functional testing. All of this ultimately is set to help strengthen and stabilize your operations and your user experience. So let's start with some terminology. First, we'll start with workload. That'll be paramount to not only resiliency but other well-architected sort of movements that we'll be doing. So workload really is a set of resources, the data that the resources use, and the infrastructure that the resources use that all come together to meet some sort of outcome. So it's technology, it's also people and process as well. So typically they're designed by architects working with the business to understand what objectives are, and they're built by a workload team of makers, developers, that kind of thing. Some of the criteria for classification include how is it being used, what characteristics does it have, and what patterns does it have? What are some of the influential drivers? What's the intended audience for that specific workload? So as we go through the well-architected framework documentation that's recently been published, you'll find that for every workload, there's trade-offs. Specifically for reliability, there'll be trade-offs for operational excellence and performance and things like that. So going into the next term that you'll hear quite a bit is resiliency. So resiliency is a quality attribute of reliability. So within the well-architected framework, there'll be a pillar for a reliable workload. Reliable workloads are resilient. That's a quality attribute. They're also available and have high uptime. So in our case, resiliency is we're going to look to be able to quickly identify faults, any sort of outages. We're going to try to tolerate those faults as best as we can, with proper error handling. We're going to look to how we can keep our workloads efficient, so doing some code refactoring and quality, how we can implement monitoring, so if something does go down, how can we get alerted, building in a testing strategy so that we can test everything as it's running as expected, but also as we're deploying new features and functionality into our application. And then looking at our business continuity and disaster recovery plan so that we have potential for disaster recovery drills, who owns roles and responsibilities when it comes to SaaS applications, and then declaring terminologies within there. So what's our RTO and our RPO, and things like severity level and criticality levels. So speaking of criticality, we'll go into sort of how do you sort of tag a workload as critical to the business. Is it a high critical? Is it lower, just maybe for just personal productivity? So that's key to what we'll be doing here as we look at workloads that need to have that sort of resiliency applied to it, as the criticality levels to it. For, as we talked about BCDR, building in that recovery strategy to meet our SLOs. So with Power Platform and most SaaS, you do have SLAs that come with that licensing, but there are potential areas where you could be expanding into the Azure cloud, other clouds, on-premise resources. So how can we, prepare for an unforeseen event, and try to reduce any sort of downtime, any sort of data loss, anything like that? So, we'll look at some of the strategies, things to consider, and some tools there. Finally is the well-architected framework assessment. So that's something that's been put out by the PowerCat team. It's an assessment tool where you can go maybe identify one of these workloads and then pick one or more pillars. So reliability, operational excellence, performance, security, things like that. And take this assessment, and it'll read out and provide you some updates. It's a very, very good tool, very elegant tool. It's free to use. I highly recommend using that. And I'll have links down at the bottom of this video that you can click into to go to that assessment directly. All right, so where to start? How do I even get started working out the resiliency piece of it? Well, if you've done the assessment, it's sort of giving you a sort of point in time of where you're at, and that's obviously a good thing. So I'd start probably with that well-architected framework assessment. But think about where you're at in the application lifecycle. Are you still in the design phase? Are you developing? Have you gone live with this application? Resiliency can be applied really at any phase of it, but obviously the earlier you can get, the better. But we want to find out first, where are you at in that life cycle? Have you identified critical workloads? Even if you're in the design phase, what's going to be critical to your business, that cannot have the downtime, cannot have any sort of disruption? So identifying those critical workloads, there's different techniques that can be done. What I'd recommend is looking at, if you don't know and you're already live, thinking about what your business needs to run. Those are probably pretty critical workloads. Other things, that you can do if maybe you're at a broader scale, that you're having to look across many environments. For instance, you might be a Power Platform admin. How to identify critical workloads. There's things like Center of Excellence, if you have it, that could show you things like the flows, how many times it's used, where it's being used, how many times it's run. There's the tenant level analytics as well that can show you the number of runs. There's even inside of the Power Platform Admin Center, there's different dashboards for analytics that'll show you the number of flow runs, the Power Apps, how many times it's used, Dataverse, how many times a plugin is being used, or writes are happening to a table, for instance. All of those, I think, can help you pinpoint what would be considered a critical workload. And I would write those down and be sure to apply a criticality assessment to them, sort of say, hey, this is high, medium, low, and go through the FMA analysis that's documented, right? So that's a failure mode analysis. And that, I think, entails the next piece, which is, reviewing the architecture and complexity of those critical workloads. So making sure that, we keep it as lean as we can. We don't try to add in unnecessary complexity, any unneeded dependencies, applying that criticality label like we mentioned before. And then, asking yourself, are you performing code reviews on those critical applications? Have you introduced deployment quality gates on your deployments? If you're not using automated deployments, have you got a plan to automate deployments? But assessing where you're at with all of that can help us sort of at least figure out where we are in our resiliency posture and work towards strengthening or stabilizing specific areas so we can improve our resiliency. All right, you've done the assessment, You have, thought about all your critical workloads, you've tagged everything, you've applied criticality ratings, you've gone through all of that. Now what? How do I build a plan to sort of strengthen my posture? Start small. Plan for incremental improvements. Just, for instance, if you're not doing code reviews or having approvals on deployments, maybe look at adding that. There are very easy ways, depending on how you're using or deploying. For instance, if you're using things like ADO, GitHub, maybe even pipelines, where you can add sort of these environment checks around it. So you can have things like approvals, code reviews on movement of solutions or apps from dev environments up the swim lane to production. So adding those in are not big efforts, and can at least get you started towards strengthening your resiliency posture. Review the documentation that's out there for anything deprecated, any limits that the platform can apply, from API limits to entitlement limits, things like that. Anything that can cause potential disruptions to the platform. If you have done the criticality assessment and you've identified the infrastructure that is running on your workloads, look for anything that can be deprecated. For instance, if you're using a connector or action inside of a Power Automate flow that is deprecated, that is a sure sign that you need to work on strengthening the resiliency by finding another avenue to address whatever business need is there. I would recommend having at least one resiliency activity added to every deployment cycle. Again, they don't have to be big. They can be small things like adding a code review to this particular app or flow inside of this workload. And finally, plan for resiliency checkup activities. I think these are important to do every so often. Assess your workloads using that same assessment. So keep that assessment handy, the one you started with earlier, and then maybe 90 days, 180 days, something. Go back, run that assessment again, and compare the delta. There's tools out there that should be able to help you sort of slice and dice how those look. But ultimately, you want your score to be higher. You want to show that you've made improvements in your resiliency posture. All right, let's talk strategy and tools. All right, so you've got the plan, and you're starting to incrementally sort of add resiliency into your workloads. Here's 5 things I think could help start that discussion. We can make those little incremental improvements using code quality, with error handling, adding monitoring and testing, and then planning for your BCDR strategy. All right, so code quality, even if it's a low code platform, pro dev platform, code quality should still be top of mind. It's fundamental to all applications. It impacts everything from performance to usability, and of course, in our discussion here, reliability and resiliency. So first and foremost, all of those critical workloads that contain those customizations, they need to be in source control. Source control is going to allow us to be able to review the changes, allow us to be able to run things like code reviews, do peer checks, whatever it would be. But first and foremost, get that stuff into source control. There's tools for Power Apps to take that app, extract out the YAML files, and put those into source. Power Automate, take that JSON, put it into source. Dataverse, any plugins you have, any web resources, whatever it is, get that into source control. I've created videos in the past that go into different tools and how to go about this. I'm linking to one here. Doesn't necessarily go into the tools. There's another link. It'll probably show up next to this one, but this one's called Refactoring and Code Quality. It just looks at the benefits of refactoring code, not carrying around extra code if it's not needed, and just benefits of keeping sort of code hygiene top of mind. All right, so here's just examples of code quality tools. So in Power Apps, the designer, as you're designing, can tell you with I think it's called Power Apps Checker, will tell you things from accessibility to other sort of areas of concern to address. Copilot is there as well to help with some of the code quality. Again, put it in source control. Why? Because you can do things like run Solution Checker, which is the Power Platform code review tool that's out there. There's obviously third-party code review tools as well, but source control is going to be needed for all of that. For Power Automate, again, the designer has the same thing. Source control, solution checker, same thing. You see that applies to Dataverse and Copilot Studio. Dataverse has copilots itself. Like, for instance, since you're writing standard JavaScript and C#, there's opportunities for things like GitHub Copilot to come into play to help you sort of refactor the code. And then Copilot Studio has that designer where you can, test it out and look at, sort of where the topic is going, and kind of see if there's ways to improve and reduce any sort of redundant actions or anything like that. All right, let's get into error handling, right? First, never assume that an action is going to succeed. You got to plan for something that's going to be unforeseen to happen. We used to use things like try catch blocks, things like that within error handling. One of the things I would say is that when you're anticipating writing for error handling, make sure you handle the error gracefully. Don't just throw a standard basic exception back. Try to return something meaningful back to the user. It should say sort of what's happening, but maybe something that's not too low level, so that they could inform them to maybe retry something to do that. But it should be robust enough to also inform any sort of IT support staff to be able to troubleshoot. So making sure that what you're providing is something that's readable, but also robust enough to help sort of solve the problem as it comes up. All right, so we mentioned, for instance, on code quality, some tools you could use. Well, you can check with when you're doing code reviews, for instance, for your Power Apps. How are they working? Are they using error and notify functions? Error functions allow us to sort of handle anything that may have happened. So if you have connections with Power Automate or other connectors, you can check for errors. You can do notify to notify a user that something's happened with your own sort of message in there. In Power Automate, I've wrote lengthy examples of how to create try-catch blocks, how to implement error handling within Power Automate. You can find that in the Monitoring the Power Platform series that I wrote. The scope action is fundamental to that. So review scope action and how you can configure subsequent actions based on the output of the scope action. And then you also consider the response payload. If you have the ability to pass in specific or pass back specific codes, messages, etc. within the payload, that can help you sort of tell the user what's going on, tell the IT support staff, hey, how to go fix me. Also consider things like terminating the Power Automate flow with a specific status. Maybe it's like failed status, for instance. On Dataverse, we have business logic, so that's typically your plugins. You'll have an invalid plugin execution exception message. So that's something you want to pass back. That tells the platform that this is a handled exception. It'll write to, for instance, logs. It'll write to the plugin trace log. You can also, add in sort of logging as well. We'll talk about that here in a bit. But that's the standard sort of object that you want to pass back to the platform when there is an error occurring in your business logic. For Copilot Studio, there's error codes that'll be sent back to the user. You can add additional responses to the user to tell them to notify, administrators or whatever it may be, so that they can let them know, so that you can troubleshoot that bot session that happened. All right, so let's talk monitoring. At a high level, monitoring is your ability to extract the information about how your apps and platforms are being used, how it's performing, and the evolution of your business data. So insights are collected will show you how your business operates. Having that strategy in place would be best when you're planning your solution, but there's no bad time to get it started. I have plenty of information on this. You can see a YouTube video, I'll link at the bottom, called Defining a Monitoring Strategy. Okay, here's just a slew of tools and thoughts on where you can go from business data, tenant environment data, and operational data. What's covered up behind is a service communications API that gives you things like message center, outages, things like that. You have Purview, telemetry export, Dataverse, Power Platform APIs, Fabric, Dataverse for business data. For the extraction layer, you can extract those data points using data activators, blob storage, Power Automate functions. You can alert, analyze, and report using Azure, for instance, Monitor and Sentinel, or use Power pillars such as AI Builder and Power BI. Plenty of information available online to be able to work with different areas of monitoring data, for instance, business or operational. Okay, let's go move on to testing. So, testing helps us rehearse our mission critical or critical workloads that we have. It's imperative before we deploy to production that we've tested. It adds quality checks and guarantees avoiding costly challenges. It helps us be efficient, provide safety, and detect defects as soon as we can. When you're developing, the scope will always grow. There's new stuff that's being added, new features and so on. So your testing will grow, and you'll have to, sort of understand how to sort of build my test with test plans and test cases that can be combined within a test suite that can, be used to help identify where there could be places where we could improve our resiliency. So a good opportunity here, and we'll move from testing into the next piece, which is disaster recovery. But, when you're developing, just remember you're going to have unit tests and things developers are going to build. Those can then be turned into regression, testing those existing features that have now been deployed out. So when you're building your testing strategy, just consider, what is important to you and make sure it's covered. You can add code coverage as well to just sort of, further strengthen your resiliency, making sure that you've covered all the code across your application, with testing. Here's just some examples within a project, right? So testing business project processes, what's in scope and how are they identified? Business requirements, how are you prioritizing and validating that you're meeting those requirements? Any design requirements. So, is there anything that needs to be looked at that could be considered functional reporting, et cetera? For data, how are you validating data migrations, any integrations, and everything is moving along as expected? For geo, how do you make sure you're testing for specific requirements, maybe related to language, maybe related to regulatory standards that are within each geo, for instance. And we call it high risk again with the criticality workload. Make sure you've identified what needs special attention and that you do have a test in place for those critical workloads. All right, let's move on to the testing tools. Here's again some examples for Power Apps. You have Power Apps Test Engine, UI Test Framework. You can use the Pack CLI for testing. For Power Automate, there's the Designer has a tester in it. So when you're running and you're executing one, you can replay it to test it with changes you've made. For Dataverse, you can do unit testing. There's UI test frameworks that are out there. And for Copilot Studio, there's a tester within the Designer for Copilot Studio, and there's also the Copilot Studio Kit that is also out there that can help you, test your Copilot and monitor how it interacts with your users. Okay, let's move into our final topic, which will be BCDR. So, you want to perform the analysis of your critical workloads, like we talked about before. Tools like Center of Excellence, Business Value Toolkit can help if you struggle with, figuring out which ones are which are critical, and maybe you're broad tenant admin with hundreds, thousands of environments that you need to monitor. So those tools can help there. Make sure you have clearly defined roles and responsibilities for the team who manages that workload. So in SaaS, that means applying responsibility to the provider as well. So if you're in Power, for instance, Microsoft has roles and responsibilities, but it's a shared responsibility with Microsoft and the organization. Have an escalation path with clearly defined terms for RTO, RPO, severity, incident closure. You can find documentation on that within the well-architected framework guidance. And for any workload where you can conduct DR drills, I'd recommend performing those at least yearly. For tools, Azure Chaos Studio works well for Azure workloads. It's an evolving tool, so more resources will come aboard where you can simulate any sort of disaster. There's also ideas of being able to turn things off and on that we'll look into here in a bit. Okay, so if you're gonna conduct a DR drill, here's just some tools. There's probably plenty out there, but making sure that you have a DR drill in place is important. So for Power Apps, some things you can do is disable gateways on lower environments. We don't necessarily need this production, but a production-like type environment. would be helpful here. So disabling gateways, API management, you can actually respond with failed error codes and so on. Disabling Power Automate flows that are being used and seeing how Power Apps will respond to that. For Power Automate, any dependent child flows, can be turned off. You can also, for some connectors, set up the static results and mimic an error coming back, maybe like a throttling error, and see how you handle that. For Dataverse, disabling the on-premise gateways, turning on Azure Chaos Studio if you're using things like Azure Functions, stored service buses, event hubs, things like that. For Copilot Studio, again, similar. If you're working with gateways that are pulling information locally, you can disable those. Disabling topics that would be interacted with, you can turn those off and see how it will respond. Again, API M and Power Automate flows for any sort of integrations you may have. You can disable those and be able to run a disaster recovery. I think the biggest thing, though, is whatever tools you end up using, make sure you documented it. And if you find an error, go back to what we talked about. Is that needed? Can I remove it? So that's going into that code quality and that architectural design review. If it's something I do need, am I adding in proper error handling? Am I doing looking out for transient faults and adding like retry patterns, for instance? So consider what you get out of this as opportunities for the next steps that you'll have to do to strengthen your resiliency posture. Okay, we've come pretty much to the end of this, very beginning, very, overview of defining a resiliency strategy. Some of the considerations here is as you implement monitoring, review your error handling and code quality, consider what you can do to improve. Like for instance, in monitoring, you may have App Insights turned on. Good first step. But maybe think about adding visualizations, building a dashboard that someone can go to and quickly see the state of every sort of workload infrastructure that's there. If you're doing code quality and you're running code reviews, for instance, and these tools are pointing out that there's quite a few violations, work at chiseling down those list of violations and continue running code review to make sure you're not introducing new issues into your code. For testing, always review your code coverage. Make sure you have ample testing across the board. Pre-production environments work very well here, where they're production-like type environments, and those can be spun up and down using automation if needed as well. And BCDR, always look at refining what that is. I would say always do at least a yearly review of what your plans are. Document your RPO, RTO. Any SLAs, there's the trust documentation for Microsoft has Power Platform and a lot of our SaaS resources, sort of what that SLAs are, how many nines it is, things like that, that are out there to be consumed. So, store that, keep those links handy. And I'd say finally for next steps, again, run that assessment, do what you've heard today, at least plan for it. And then come back to it, 3 months, 6 months from now and see, have I really improved my resiliency? Because as you improve your resiliency, you'll probably improve other things like security or operational excellence. We talked about introducing quality gates into your deployment. Well, that's going to be, or even just automating your deployment, that's going to help with your operational excellence. So you can knock out 2 birds with 1 stone here. So as you're, strengthening one thing, you may actually be strengthening another. So now's the time to get started on it. And I look forward to hearing about all the progress and great things that you'll be doing with what you've learned today. Thank you, everyone. Have a good rest of your day.